So here's some of the equipment that we're going to be using in this experiment. But before I tell you about how to do the experiment itself, I want to talk about just a few sort of housekeeping issues. So first of all, the way in which we get our theoretical accelerations in this experiment is we do free body diagrams for various pieces of the apparatus, and then we turn that into a force equation and we solve for the acceleration. A lot of students find this a bit tricky, so I have put an optional help video on the website just to help you with your pre-lab. So if you're having trouble with the pre-lab, watch that optional video, it may help. Next thing I'll mention is that this is actually one experiment where it is possible to finish early. Not everybody does, but if you're on the ball, I have had groups finish in as little as an hour, so that's something to work towards if you want to. Next, I know I'm always harping at you guys to level your track carefully, but this is one experiment, especially for the first trial, where if you don't level your track accurately, you're going to have a lot of trouble getting good agreement between your values. So do this as carefully as you can. The next thing I'll talk about is actually part of the experiment. You need to weigh 3 masses. So there's a table in your lab manual and you need to fill that in. So one of the masses is the cart with all of its added masses stacked on top of it. Second thing you weigh is the mass hanger. I know it says 50 grams on it, but you should go and weigh it yourself. And then the third thing you weigh is all of that together. So you put the mass hanger on top of the cart with all of its added masses, and you weigh it as one big chunk. The electronic balances to weigh these things with are over on the side counter beside the sink. There's also a scale sort of tucked in behind the lab room door. That's a little hard to see. Feel free to ask your lab instructor to point it out. Okay, now I will tell you about how to do the experiment itself. So in this experiment, we're going to be measuring accelerations that are created in 2 different ways. The first trial is identical to something you did in Lab 5, where you've got a cart with added masses on it, and it's connected via a string over a pulley to a mass hanger, which is going to provide the force that accelerates the cart down the track. So that's just like what you did in Lab 5. Now, before you actually get your experimental value, you're going to calculate the theoretical value. And you do that by creating a free body diagram for your cart, and also a second one for the mass hanger, dangling down there, and you use those to get a force equation and solve for the acceleration of the cart. So you do that first, and then you would run the trial just like you did in Lab 5. So you would release the cart down the track, capture a graph of it, fit a straight line to the VT graph to get your acceleration. You would then compare the value you got from your free body diagram analysis to the value you got from your graph and see whether they agree with an uncertainty. In the second trial, we're going to accelerate the cart in a completely different way. So to begin with, you take the string off completely, so you're not going to use that mass hanger at all. Second, I actually recommend that you take these masses off entirely. Strictly speaking, you could do this second trial with the masses on there, but it makes things more violent and noisy, so I'd prefer you didn't. What we're going to do to accelerate this cart is we're going to tilt the track. So you grab your brick and you put it under the sensor end of your track, and now the cart will accelerate just due to gravity. So again, you're going to get your theoretical value for the acceleration first. You make a free body diagram of the cart and you solve for acceleration. But one of the things you're going to need in order to get that theoretical value is you will need the angle of the track. So we have this little gizmo here. It's got a swinging arm in it, and you just sit it on top of the track, and then you can read your angle off of there. The percent uncertainty of the angles tends to wind up being pretty high, so you will get a smaller percent uncertainty if you try and make the angle of your track a little bit steeper. You don't want to go too steep just because it'll get noisy and violent, but a little steeper means that the percent uncertainty ends up being smaller. So that might be something you try to do. So once you've got that angle, you're ready to calculate your theoretical value for the acceleration, and then you can get your experimental one. So again, it would simply be a case of start the program using the acceleration program as you've used before, and then you would just release the cart down the track. Make sure you start at least 15 centimeters away from the sensor, let it accelerate, capture that motion, fit a straight line to your VT graph in order to get your acceleration, and then you're finished with the experimental value. You can compare your experimental value that you got off your graph to the one that you calculated theoretically and see whether or not they agree with an uncertainty.